GCSE Physics, Parallel Circuits. Parallel circuits, independence and isolation. In parallel circuits, each component is separately connected to the positive and negative of the supply, except emitters, which are always connected in series. If you remove or disconnect one of them, it will hardly affect the others at all. This is obviously how most things must be connected, for example, in cars and in household electrics. You have to be able to switch everything on and off separately. Everyday circuits often include a mixture of series and parallel parts. Potential difference is the same across all components. In parallel circuits, all components get the full source PD, so the potential difference is the same across all components. This means that identical bulbs connected in parallel will all be at the same brightness. V1 is equal to V2 is equal to so on. Current is shared between branches. In parallel circuits, the total current flowing around the circuit is equal to the total of all the currents through the separate components. In a parallel circuit, there are junctions where the current either splits or rejoins. The total current going into a junction has to equal the total current leaving. If two identical components are connected in parallel, then the same current will flow through each component. I total is equal to I1 plus I2 plus so on. Adding a resistor in parallel reduces the total resistance. If you have two resistors in parallel, their total resistance is less than the resistance of the smallest of the two resistors. This can be tough to get your head around, but think about it like this. In parallel, both resistors have the same potential difference across them as the source. This means the pushing force making the current flow is the same as the source PD for each resistor that you add. But by adding another loop, the current has more than one direction to go in. This increases the total current that can flow around the circuit. Using V is equal to IR, an increase in current means a decrease in the total resistance of the circuit.